Now today we are going to discuss about solubility. What do you mean by solubility of a substance? Solubility is the maximum amount of substance, that is our solute, that can be dissolved in a given amount of solvent at a particular temperature. First, let's discuss the factors that affect solubility. Now here we are going to discuss the solubility of solid in liquid and solubility of gas in liquid. So first let's discuss about the solubility of a solid in liquid. And let's discuss the factors that affect the solubility of solids in liquids. The first factor that affects solubility of a solid in liquid is nature of solute and solvent. So, factors affecting solubility of solid in liquid. One is nature of solute and solvent. Now here we use the principle like dissolves like. That is, suppose the solute and solvent both are polar in nature. So polar solute is soluble in polar solvent. For example, ethanol and water. Ethanol, water mixture. Both ethanol as well as water is polar in nature. So both are soluble. Now if the solute is non-polar, that will be soluble in a non-polar solvent. For example, naphthalene. Naphthalene. It is soluble in benzene. Here, naphthalene as well as benzene both are non-polar. But we know naphthalene is insoluble in water, but it is soluble in non-polar solvent benzene. So this is the rule, like dissolves like. Polar solute is soluble in polar solvent and non-polar solute is soluble in non-polar solvent. Now, let's take an example to discuss the solubility of solid in liquid. An example, when I say solid in liquid, the solute is solid and solvent is liquid. So this is a liquid solution. Now I'm taking the example, solute as sugar and solvent as water. So first you take sugar and dissolve it in water. We can see that in the beginning the concentration of the solution increases. And you keep on adding sugar to water. After some time you can see from the solution the sugar molecules will start separating out. And the process of adding sugar to water or dissolving solute in solvent is known as dissolution. Dissolution. And I told you after some time you can see the sugar molecules will start coming out of the solution and we call this process crystallization. And finally we can see the rate of dissolution will become equal to the rate of crystallization. That is, the number of sugar particles going into solution and the number of sugar particles coming out of solution will become same. Or we say that solution has reached dynamic equilibrium. And we can show that equilibrium as solute plus solvent in equilibrium with solution. Now at this stage, at equilibrium stage, it is not possible to add more solute. Or we can say that now the solution has become saturated. Or at equilibrium, the concentration of the solution remains the same at that particular temperature. Or we say the solution is a saturated solution. So we can give a definition for saturated solution. Saturated solution is a solution in which no more solute can be added at a given temperature and pressure. Whereas unsaturated solution means unsaturated solution means a solution in which more amount of solute can be added. Okay, so we can use the term solubility for a solution, or we can use the term concentration of a solution at its saturated stage. Next, let's discuss the second factor that affects solubility, that is effect of temperature on solubility of solids in liquids. So the second factor is temperature. Now, we can say that if the dissolution process is endothermic, then the solubility of a substance or the solubility of a solute in solvent increases with increase in temperature. So, if the dissolution process is endothermic, then solubility of a solid solute in solvent increases with increase in temperature. Let's see how. We know that if the dissolution is endothermic, means we have solute plus solvent plus heat in equilibrium with solution. So this is an endothermic process. Endothermic process means heat is absorbed, and we know that for an endothermic process delta H value is greater than 0. So you can see, according to Le Chatelier's principle, the forward reaction is endothermic. The forward reaction endothermic means this reaction takes place at high temperature. So as you increase the temperature, more and more solute will dissolve in solvent, leading to the formation of solution. So we can say, if the dissolution process is endothermic, then the solubility of a solid in liquid increases with increase in temperature. Now the second case is, if the dissolution process is exothermic, then the solubility of a solid in liquid decreases with increase in temperature. So let's see the second case. This is the first case and this is the second case. The second case is exothermic. So solute plus solvent. In equilibrium, you get solution plus heat is released. So if it is exothermic, we know delta H value will be less than 0. So if it's an exothermic process, I told you the solubility of solid in liquid decreases with increase in temperature. Now, applying Le Chatelier's principle, you can see the forward reaction is exothermic, means the forward reaction takes place at lower temperature. So, as temperature decreases, more and more solute will dissolve in solvent, leading to solution. Okay, whereas the backward reaction will take place at higher temperature. So, if the dissolution process is exothermic, then the solubility of solid in liquid decreases with increase in temperature. Or we can say the solubility of solid in liquid increases with decrease in temperature. So forward reaction, exothermic, low temperature. So the solubility will increase with decrease in temperature if the dissolution process is exothermic. So this is the effect of temperature on solubility of solids in liquids. Now let's see the third factor that affect the solubility of solid in liquid, that is pressure. Now, pressure has no effect on solubility of solid in liquid because both solids and liquids are highly incompressible. So, pressure has no effect on solubility of solids in liquids. So, with this we finish the solubility of solids in liquids and the factors that affect solubility of solid in liquid. The first factor is nature of solute and solvent. Second factor is the effect of temperature. And effect of temperature is the solubility of a solid in liquid increases with increase in temperature if the dissolution process is endothermic, and the solubility of a solid in liquid decreases with increase in temperature if the dissolution process is exothermic. And the third factor is pressure. Pressure has no effect on solubility of solid in liquid because the solids and liquids are highly incompressible. Next, let's discuss the solubility of a gas in a liquid. We know that many gases dissolve in water. Certain gases will dissolve to a smaller extent, whereas some gases will dissolve highly in water. For example, oxygen gas is less soluble in water, and we know that this dissolved oxygen is responsible for the aquatic life. And hydrogen chloride gas, it is highly soluble in water. Now let's see what is the effect of temperature on solubility of gas in liquid. So, effect of temperature. Yes, effect of temperature on solubility of gas in liquid. Now, as temperature increases, solubility of gas in liquid decreases. As temperature increases, solubility of gas in liquid decreases, because the dissolution of gas in liquid is an exothermic process. So when we write like this: a gas plus solvent is in equilibrium with solution plus heat is released. So you can see, according to Le Chatelier's principle, the forward reaction is exothermic. It takes place at lower temperature. So lower temperature, forward reaction take place means more and more gas will dissolve in solvent and it will lead to solution. So as temperature decreases, solubility of gas in liquid increases. And we can see the aquatic species, they find more comfortable in cold water rather than in hot water, because cold water temperature is lesser. So as temperature decreases, solubility of oxygen in water increases, whereas in hot water, as temperature increases, the solubility of gases will decrease. Okay. Let's discuss the effect of pressure on solubility of gases in liquid. The solubility of gases in liquid increases with increase in pressure. That is, as pressure increases, solubility of gases in liquid increases. For example, you consider a system, and the system, the lower portion of the system, we have solution, and the upper portion we have the gaseous system, gaseous particle or gas particles. Now you can see in the beginning few particles, gas particles will go into the solution, and after some time some particles from solution will come back to gaseous state, and finally you can see an equilibrium is established between the solution and gaseous particles. Now suppose I compress these gases by applying pressure. So we have some gas particles in the solution here. Now I compress this gas particles by applying pressure. So you can see in the solution more number of gas particles will be present. So this is our solution and this is our gaseous system. So after compressing, you can see I compressed it by increasing the pressure. When I increased the pressure, more number of gas particles went into the solution. So you can see as pressure increases, the solubility of gas in liquid increases. And finally, a new equilibrium is established in this container. Okay, so that is the effect of pressure on solubility of gas in liquid. As pressure increases, solubility of gas in liquid increases. Now, a quantitative explanation for the pressure of gas and solubility is given by Henry's law.